Today, we're going to pull back the curtain on a hidden prejudice. But this isn't a bias found in people. Nope, it's baked right into the AI systems that we're starting to use for, well, almost everything, from scanning resumes to making medical calls. It's a pretty startling bias against neurodivergence, and it's been hiding in plain sight.
Okay, let's just jump right into the most shocking finding from this research, because you kind of have to see it to believe it. So researchers tested how AI models feel about certain sentences, their positive or negative vibe. And the results are, well, they're wild. A sentence like, "I have autism," was rated as having a stronger negative association than "I am a bank robber." I'm going to say that again. According to the AI, saying you're neurodivergent is worse than saying you're a criminal.
So right away, the big question is, how? How is that even possible? We're talking about a machine, right? It's just code and data. How can it possibly hold a prejudice? To figure that out, we have to peel back the layers and see how an AI actually thinks. And the answer, really, it all comes down to this one core concept called word embeddings. It sounds technical, but this is the magic that lets an AI understand our language. And as it turns out, it's also the crack where the bias seeps in.
So, what on earth is a word embedding? Think of it like this. It's a way for a computer to turn words into numbers. Every single word gets a unique code, a string of numbers called a vector. Now here's the crucial part. Words that the AI has learned have similar meanings get codes that are mathematically close to each other. So, in a way, meaning becomes a location in this huge, multi-dimensional map of words.
Let's make that a little more concrete. Imagine a simple line, like a ruler. On one end, you have the concept of bad, and on the other end, good. The AI would learn to place the word robber way down near the bad end. And a word like nurse, that would be placed much closer to the good end. Simple enough, right?
Okay, but here's where it gets really interesting. Let's add another line, a second dimension, going from non-human to human. Now all of a sudden, our map has way more depth. Nurse and robber are both close together on the human axis, but they're still miles apart on that good/bad axis. And get this? A real AI language model doesn't just use 2 dimensions, it uses over 100 dimensions, creating this unbelievably complex map of meaning based on how we humans have used words in billions of texts.
And this is where the problem just slaps you in the face. The study showed that in this massive, complex map of words, terms like autistic and schizophrenia are placed mathematically closer to really stigmatized words like loner, stalker, and obsessive. And at the same time, words like typical and normal are clustered right next to positive words like fun and outgoing. The AI didn't invent this, it just learned our own societal biases from the text we fed it.
So, it's one thing to see these clusters, but how do scientists actually measure this stuff? How do you prove it and put a number on it? Well, they have a specific tool for the job, kind of like a detective's toolkit. And that tool is called the Word Embedding Association Test, or WEAT for short. You can really think of it as a forensic test for AI bias. It's designed to measure the strength of the connection between different groups of words. So, for instance, it can spit out a hard number, a score, that tells you exactly how strongly an AI connects neurodivergent terms with words related to, say, danger.
Okay, so now we know how they test for it. Let's get to the evidence. What did running these WEAT tests actually uncover about the prejudices hiding inside these AI models?
This chart pretty much says it all. The researchers tested 11 different AI models, and what you're seeing here are the average bias scores. Look at that. Neurodivergent terms were strongly associated with concepts like dangerous, unattractive, and uptight. A high positive score means a strong bias, and these scores are high. The data just leaves no room for doubt.
The authors of the study really didn't mince words. Here's a direct quote. The highest WEAT scores associate neurodiversity with slurs, violence, and being uptight. So we're not just talking about a subtle accidental bias here. This is a powerful, statistically measured prejudice.
But here's the part that is just mind-boggling. The bias doesn't just stop with negative stereotypes. The researchers thought, hey, what about the positive strengths often linked with neurodivergence? Well, the results were just as backward. Honesty is often seen as a strength for autistic people, right? The AI actually associated them more strongly with being dishonest. It linked reliability with being fickle. It linked being accepting with being judgmental. The AI is literally biased against their strengths. So the evidence is pretty overwhelming. The AI systems that we're leaning on more and more every day have this massive, serious blind spot. And that brings us to the most important question of all.
What in the world can we do about it?
The good news is this isn't hopeless. The paper lays out a really clear path forward. First, we can take the fairness and debiasing tools we've already built to fight gender and racial bias and apply them here. We absolutely have to start testing systems like AI-powered resume scanners, because that's where this bias can cost someone a job. And maybe most critically, we need more neurodivergent people in charge, in leadership roles, developing AI, and bringing that essential lived experience to the table. And of course, we need to keep digging to really understand how this digital stigma affects real people in the real world.
In the end, this whole thing leaves us with a really deep question to chew on. These AI models, they learn from us. They're trained on this gigantic collection of human writing, our books, our articles, our endless online chatter. They're basically a mirror reflecting the patterns and biases that already exist in our own language. So when we find a deep-seated prejudice in the machine, we really have to ask ourselves, what is it telling us about us?